Okay, we are back on and recording, and we are now going to talk about Newton's laws. And really, all of Newton's laws can be summarized with one equation. But before we get to that equation, which is surprisingly simple, we need to talk a little bit about what acceleration is. So we were just talking about distance. You know what distance is. It's how far you've walked. So if here's somebody walking, and he's walking down the road, and here is position 0, and here is 1 meter. We all understand that he's a very small person. Okay, he's a wee one. It could be 1 mile, but we don't know. It can't be 1 mile. It could be 1 kilometer. Okay, we don't use miles in physics because they're really annoying to convert into units that work with the other equations. So anyway, he walks this kilometer. We understand that's an everyday concept. We understand velocity. That's how fast he's moving, how fast he's walking that kilometer. And position is simply measured in the units of meters. Okay? Velocity is measured in units of meters per second. And acceleration, which we're less familiar with on in everyday life, is in units of what? Anybody know? Andre?
Meters per second.
Right. Meters per second per second. Now let's talk about that a little bit. Okay, it makes sense. Erase this man. Okay, meters per second per second. The best way that I've found to understand this is to think about dropping stuff. All right? Dropping stuff is a lot of fun, and especially if you're way up on a big cliff. So here's a cliff, and here's our man up on the cliff, and he's kind of leaning over, and don't lean too far, and he's going to drop something. He's going to drop a rock. There's a rock. So what is the velocity of the rock? Let's draw our axis here. Okay, so here's our. Here's our axis, and I'm going to draw this upside down just because it's easier for right now. Okay, so this is going to be. Oh, hold on a second. We don't want to use arrows. We want to use lines. This will be position 0, 10 meters, 20 meters, 30 meters, and 40 meters. Okay. So and I can label this 10, oh, that's not it, 20, 30, 40, and 50. Okay, so he's going to go ahead and drop that rock. What is the velocity? Oh, wait a minute. I made a mistake. Hold on. This should be 0, right? 0, 10, 20, 30, and 40. Okay, Nicholas, what is the velocity at 0 meters, right, as he's dropping the rock? What is the velocity of the rock? Yeah. Yeah, nothing. 0. So the velocity here is 0 meters per second. Now, so he drops the rock, and now we measure the velocity again after 10 meters. And I'm just going to make a number up, I think, 9.8 meters per second squared, but that doesn't tell me. Yeah, so I'm just going to make a number up for the sake of this picture. So let's say after 10 meters, it's now going uh, let's say he's dropping it on another planet somewhere, okay, where all the units are just right. So on this other planet, now it's got 1 meter per second is the velocity. So it gained 1 meter per second falling 10 meters. What do you think the velocity is going to be after 20 meters? Nicholas? I think so. I hope I'm doing this right because I'm being recorded. Okay, I think it'll work. 2 meters per second. And here, it's 3 meters per second. And here, it's 4 meters per second. So the velocity is changing. Okay? The velocity is getting bigger as time passes. Now, let's adjust our thinking over here. Let's get rid of these, instead of looking how the height of the rock, let's look at how much time has passed. Okay? Yeah, and this is where we kind of made a little bit of a mistake here. All right, and that's okay. We can let's I think you're getting the idea though that as the velocity is changing over time. I'm just going to simply redraw the way I've done this. Okay, real quickly here.
Now,
Yes.
what makes the velocity velocity? And in other words, why isn't it acceleration instead of velocity?
Velocity.
It seems like it would be acceleration if it's changing over time.
Okay, the velocity is how fast the object is going. The acceleration is how fast the is changing. Okay, your speedometer on your car tells you your velocity. Technically, it tells you your speed because it doesn't also tell you your direction. But don't worry about that. That's for the rest of the class that heard that part about vectors. The speedometer in your car tells you the velocity. So you're going 100 miles an hour. The acceleration is what you feel, which is the car you're getting pushed into the back of your seat, right, when you're accelerating, right? Okay, so let's redraw this just slightly differently. Now what we're going to do is say this is where the rock is after 1 second. This is where the rock is after 2 seconds. This is where the rock is after, well, that's too evenly spaced. Hold on, let's try this again. Wait, that's not an eraser, it's a pen. Okay. There's zero, this is 0 seconds, 1 second, 2 seconds, and then 3 seconds, okay? So the distances are getting bigger between each thing. Okay, so if we look at the velocity now, so 0 meters per second, 1 meter per second, 2 meters per second, and then finally 3 meters per second. How many meters per second is it gaining every second? 1. So look at right here at this position, we're at 1 meter per second. A second later, we're at 2 meters per second. A second later, we're at 3 meters per second. So we're gaining 1 meter per second, which is our velocity, and we're gaining that every second. Meters per second per second. Okay? Meters per second, 1 meter per second every second. Meters per second per second. Now, this is not normally how you write this. I'm writing this just to help us learn it. The way you normally write it is 1 meter per second squared. That didn't come out very good. Let's try it again. Okay. I'll do it down here. 1 meter per second squared. It can also be written 1 meter per second, but you don't see that very often. This is really the correct way of writing it. Okay? But the idea is you're gaining a meter per second every second. And we're there, 10 minutes.